In this module, we are going to study rational expectation hypothesis. Expectations about the future values of macroeconomic variables play an important role in the macroeconomics in the determination of output and employment. Economic agents such as households, business firms, and government take decisions on the basis of current as well as expected future values of the relevant variables. For this, we have two theories of expectations: adaptive expectations and rational expectations. While the latter is much superior to the former, it also has certain limitations. Let us now discuss in detail the role of expectations, adaptive and rational expectation hypothesis, and various applications of REH. That is, rational expectation hypothesis.
After studying this module, you shall be able to know the importance of expectations in economics, understand the rational expectation hypothesis, identify the difference between rational and adaptive expectations hypothesis, evaluate the validity of rational expectations, analyze the application of rational expectation theory in the context of results of different macroeconomic models.
Let us commence our module by studying the role of expectations in macroeconomics. Expectations play a major role in economics in general and in macroeconomics in particular. Expectations about future values of macroeconomic variables play a very significant role in the determination of output and employment. Most of the macroeconomic relationships are based on expectations. It can be seen from the simple Keynesian ISLM model, permanent income hypothesis, natural rate hypothesis, and many others. First, expectations in Keynesian ISLM framework. The IS curve is very volatile and it shifts by a large amount if firms change the investment expenditure. But this shift will not affect the aggregate demand if LM curve is vertical line. It will only lead to a change in the rate of interest, but if LM is not steep, then a shift in IS will cause fluctuations in the aggregate demand originating in the private sector. The shape of IS and LM curve is based on the expectations that are formed for those variables which determine them. The firm's expectation about the future profitability of investment project will lead to highly volatile IS curve. Expectations also play a role in determining the shape of LM curve. The demand for money curve partially arises from the demand for speculative balances. This depends upon the notion of some normal rate of interest which the individual expects to prevail in the future. So, if the current rate of interest is higher than the normal rate, then the demand for money will be low and demand for bonds will be more and vice versa. When the rate of interest is at its irreducible critical minimum level, below which it will not be expected to fall, then individuals will always hold liquid cash. The shape of LM curve thus depends on the expected rate of return. It implies that in the Keynesian analysis, expectation plays a dual role. First, bring volatility in profitability of investment project which causes a shift in IS curve, and second, develop the expectations about the future rate of interest and critical rate of interest which lead to the horizontal LM curve. Second, expectations and permanent income hypothesis. The consumption expenditure of individual does not depend upon the current income as given by the Keynesian theory, but it depends upon the permanent income. Permanent income is calculated on the basis of individuals' expectations about the future income. So, actual value of consumption in any period depends on the permanent or expected income. Consumption expenditure will increase as a result of the change in income, but only after assessing that the change in income is permanent, not just transitory. If the change in the actual income does not change the expected income, then consumption expenditure will be unchanged. This implies that the process of multiplier given by Keynes will not work if the consumption expenditure is determined by the permanent income, which in turn is based on expectations. Third, expectations and the natural rate of unemployment. Workers, while deciding the supply of labor, takes into account the amount of wages they will be getting. As workers are interested not only in the nominal wages but the real wages too, they form expectations about the general price level. Based on this expectation, if the real wage is high, they will supply more labor or vice versa. The supply of labor depends upon money illusion, which implies that workers can correctly foresee the changes in prices. The above analysis justifies the significance of expectations and calls for a testable theory in order to estimate the economic variables. The problem with expectation is the scarcity of available data on expectation. Even if the collection of data does begin, it would take a number of years before a large amount of data is available. This poses a challenge in devising an appropriate theory on expectations. Despite these shortcomings, there are two prominent theories which have been built on expectations. First, adaptive expectation hypothesis, and second is rational expectations hypothesis. Let us talk these hypotheses in detail. However, we will mainly focus more on the rational expectation hypothesis. Next, we will discuss the adaptive expectation hypothesis. Adaptive expectation hypothesis postulates that people adapt their expectations on the basis of past behavior. A person will change his expectation on any variable by some fraction of difference between the variable's actual value last period and its expected value last period. The adaptive expectation can be represented by the following equation: yt to the power e minus yt minus 1 to the power e is equals to alpha into yt minus 1 minus yt minus 1 to the power e, where alpha is less than 1. This hypothesis does not predict the exact amount by which the individual will raise or lower its expectation. It predicts that if yt minus 1 is greater than yt minus 1 to the power e, then individual will raise the expectation and vice versa. Adaptive expectation hypothesis is characterized by, first, gradual process. Expectation formation is a gradual process. It takes some time for people to adapt to their expectations. They catch up to the changes in the variables eventually. Second, a general theory. Adaptive expectation theory is not peculiar to specific variables like inflation, rate of interest, rate of growth of income, etc. It is a general theory and holds for all the variables. Third, it relates the expected or unobserved variables to the actual or observable variables. This implies that expectation of any variable can be written as a function of past value of actual variable. The coefficient attached to each lagged value is less than 1 and it declines as the length of lag increases. This implies that the most recent observation dominates the expectation formation. A major shortcoming of the adaptive expectation hypothesis is that it postulates that the agent does not take into account all the available information while making expectations and always underpredict or overpredict. It means that agents ignore the information which could enable him to improve the accuracy of expectation. If the variable about which expectation is being formed is continuously rising or falling, then adaptive expectation is less than the variable itself if variable is rising and vice versa. This behavior leads to a systematic pattern in the forecasting error. Therefore, adaptive expectation assumes a suboptimal behavior on the part of agency forming expectations.
Moving on to the discussion of rational expectation hypothesis, John Muth is the originator of rational expectation theory. As per rational expectation hypothesis, individuals make their expectations rationally and use up all the available information in forming their expectations. Economic agents are assumed to be rational in the sense that they seek to best achieve their objectives subject to external constraints on their choice of actions. Rational expectation hypothesis implies that the subjective probability distribution that the individual economic agents are assumed to use in making their decisions in an economic model are consistent with the objective conditional probability distribution implied by the model. Let a variable y depends on its own past value as well as those of the other variables. Yt is equals to alpha naught plus alpha 1 into yt minus 1 plus alpha 2 into xt minus 1 plus alpha 3 zt minus 1. Expectation of yt will be given as et minus 1 into yt is equals to alpha naught plus alpha 1 into yt minus 1 plus alpha 2 into xt minus 1 plus alpha 3 into zt minus 1. Expected value, that is et minus 1 into yt, can be given by et minus 1 into yt is equals to e yt divided by it minus 1. In case of rational expectation, expectation error is 0. People do not make any mistake while making the expectation, but this is possible only if variable y is not stochastic. However, while determining the variable, there is some amount of human error which renders y as stochastic. It means that it has a random error term.
Characteristics of rational expectations, that is RE. First, zero mean value of error. Under rational expectations, the mean or the average error is zero. If y is stochastic variable including a random term, then rational expectation of y will not be perfectly accurate as v is unpredictable. Sometimes it would take negative value and its value is known only after it has occurred. So even if all the information is used to estimate y, the value of yt is not known. Thus, we take the mean or the average value of v as 0, which means rational expectation is not perfectly accurate every period but is accurate on an average. Second, no systematic error. The errors in rational expectation do not show any pattern. Under adaptive expectation, if the variables to be estimated is constantly rising, then the expectation value of the variable will be less than the actual value, leading to a positive error. So, there is a systematic pattern in the error. Under rational expectation, there is no systematic pattern in forecasting the error. We are not sure whether the error will always be positive or negative. So, if expectations are formed by rationally forecasting, error will equal to the random element v, which does not show any pattern, and therefore the forecasting error shows no pattern. Vt is equals to Bt into Vt minus 1 plus Et. Let Vt follow a systematic pattern which depends upon its own past value and some random component Et. This random component has 0 means. Here also, rational expectation would be just the unpredictable part Et because the value of y in period t minus 1 is known. Even if v shows a pattern, the forecast of y on an average will be correct and the error will not form any pattern. Third, accuracy. The rational expectation is the most accurate of all other forms of expectations. It postulates that any inaccuracy in the expectation formation arises due to the likely value of this error term v. The unpredictability of v increases with the increase in the value of v. We assume v to have 0 mean and constant variance, so the predictability or unpredictability of y would depend on the variance of v. If the variance of v is high, the more unpredictable y would be and more inaccurate its forecast of y will be. The variable of V under rational expectation is lower than the variance of V under any other method of forecasting. Rational expectation is the most accurate form of expectation.
Yt is equals to alpha naught plus alpha 1 into yt minus 1 plus alpha 2 into xt minus 1 plus alpha 3 into zt minus 1 plus vt, where vt is a random term which can be positive or negative. It is assumed to follow a probability distribution with mean 0 and constant variance. Et minus 1 into yt is equals to alpha naught plus alpha 1 into yt minus 1 plus alpha 2 into xt minus 1 plus alpha 3 into zt minus 1 plus et minus 1 into vt. Mean value of vt is equals to 0. Under rational expectation, error equals the random error term.
Second, Phillips curve and inflation employment trade-off under rational expectation. Phillips curve is a graphical representation of inverse relationship between average rate of inflation and the average rate of nominal wage inflation. It was interpreted as an idea that the relationship between inflation and unemployment would remain stable even when the government sought to use the relationship as the basis for the policy making. Under the hypothesis that the workers' expected rate of inflation following the rule of adaptive expectations, maintaining a rate of unemployment lower than the natural rate would imply an unbounded increase in the rate of inflation in the economy. If the AEH is replaced by REH in predicting the trade-off between inflation and unemployment, there exists no policy trade-off in the long run. This is because macroeconomic policy could not secure a constant and permanently lower rate of unemployment in the economy at the expense of a fixed increase in the rate of inflation. In the long run, the only rate of unemployment that can be maintained is the natural rate with the constant inflation.
Next, we will discuss the applications of rational expectations hypothesis. Rational expectations have been incorporated in many macroeconomic theories. We will consider two applications of rational expectation hypothesis. First, policy ineffectiveness proposition, which is also known as PIP. Consider the following log linear model. Yt is equals to alpha naught plus alpha 1 into pt minus et minus 1 into pt plus ut, where alpha I is greater than 0. Yt is equals to beta naught plus beta 1 into mt minus pt plus beta 2 into et minus 1 into pt plus 1 minus pt plus vt, where beta 1 and beta 2 are greater than 0. Mt is equals to mu 0 plus mu 1 into mt minus 1 plus mu 2 into yt minus 1 plus et, where yt is equals to log y, mt is equals to log mt, and pt is equals to log pt are respectively output, the money supply, and the price level, all measured in logarithms. The random terms are given by mu t, vt, and et and are assumed to be independent from themselves in time and from each other. That is, evt is equals to 0, evt square is equals to sigma v square, e mu t is equals to 0, e mu t square is equals to sigma u square, e et is equals to 0, and e et square is equals to sigma e square. Equation yt is equals to alpha naught plus alpha 1 into pt minus et minus 1 into pt plus mu t, where alpha I is greater than 0, is the expectations based on the short-run aggregate supply curve. If agents underestimate the price level, they supply too much labor and output expands. Coefficient alpha naught plays the role of potential output. Alpha naught is equals to yt star is equals to log yt star. Equation yt is equals to beta naught plus beta 1 into mt minus pt plus beta 2 into et minus 1 into pt plus 1 minus pt plus vt, where beta 1 and beta 2 are greater than 0, is the aggregate demand curve. The real balance term MT minus PT reflects the influence of LM curve, that is Keynes' effect, and the expected inflation rate ET minus 1 into PT plus 1 minus PT represents the Tobin effect. This says that higher the expected rate of inflation, lesser will be the real rate of interest, and therefore more will be the investment and resulting aggregate demand. Equation MT is equals to mu naught plus mu 1 into MT minus 1 plus mu 2 into YT minus 1 plus ET is the policy rule followed by the government. Keynesian and Tobin would believe in a counter-cyclical policy rule, that is mu 1 is equals to 0 and mu 2 is less than 0. If output in the previous period is low, then the monetary authority should stimulate the economy by raising the money supply in this period. The interpretation of the error term in the money supply equation is that central bank has imperfect control over money supply. Equating aggregate supply and demand to solve for price level, alpha naught plus alpha 1 into PT minus ET minus 1 into PT plus mu T is equals to beta naught plus beta 1 into MT minus PT plus beta 2 into ET minus 1 into PT plus 1 minus PT plus VT. PT is equals to beta naught minus alpha naught plus alpha 1 into ET minus 1 into PT plus beta 1 into MT plus beta 2 into ET minus 1 bracket PT plus 1 minus PT plus VT minus mu T divided by alpha 1 plus beta 1. Now taking expectation of PT conditional on the information set IT minus 1, we get ET minus 1 into PT is equals to beta naught minus alpha naught plus alpha 1 into ET minus 1 into ET minus 1 into PT plus beta 1 into ET minus 1 into MT divided by alpha 1 plus beta 1, the whole term plus beta 2 into ET minus 1 into ET minus 1 into PT plus 1 minus PT plus ET minus 1 into VT minus mu T divided by alpha 1 plus beta 1. Adjusting this equation, we get ET minus 1 into PT is equals to beta naught minus alpha naught plus beta 1 into ET minus 1 into MT plus alpha 1 into ET minus 1 into PT plus beta 2 into ET minus 1 into PT plus 1 minus PT divided by alpha 1 plus beta 1. Using previous equations, we get a very simple expression for the price surprise. PT minus ET minus 1 into PT is equals to beta 1 divided by alpha 1 plus beta 1 into MT minus ET minus 1 into MT plus 1 upon alpha 1 plus beta 1 into VT minus mu T. Only unanticipated shocks to the aggregate demand and aggregate supply and unanticipated money supply can cause agents to be surprised. From equation, MT is equals to mu naught plus mu 1 into MT minus 1 plus mu 2 into YT minus 1 plus ET, we get MT minus ET minus 1 into MT is equals to ET. Therefore, from the equation, YT is equals to alpha naught plus alpha 1 into PT minus ET minus 1 into PT plus mu T and PT minus ET minus 1 into PT is equals to beta 1 by alpha 1 plus beta 1 into MT minus ET minus 1 into MT plus 1 by alpha 1 plus beta 1 into VT minus mu T. YT is equals to alpha naught plus alpha 1 into beta 1 into ET by alpha 1 plus beta 1 plus Vt minus Ut by alpha 1 plus beta 1 plus mu T. Yt is equals to alpha naught plus alpha 1 into beta 1 into Et plus alpha 1 into Vt plus beta 1 into mu T divided by alpha 1 plus beta 1. Given the rational expectations, output fluctuates according to the equation. Equation says that the monetary policy is completely ineffective at influencing the output and employment regardless of the policy rule, passive or activist, adopted by the monetary authorities. This is, in a nutshell, the basic message of the policy ineffectiveness proposition.
Finally, we will discuss the criticism to rational expectation hypothesis. Despite all the rationality imparted to this hypothesis, there are major criticisms on the very basis of this rational expectation hypothesis. First, reasonableness of rationality. It is impossible to assume that an individual will have all the available information while forming expectations, because people are quite ignorant about the number of issues, and if all the information is not used up, we do not come to the conclusion of rational expectation. To counter this criticism, it is argued that it is not the individual who has to form expectations, but some government body who does so, and these people who make expectation must have all the available information. Rational expectation can lead to overprediction or underprediction, but expectations are rational and on an average accurate. Second, in economic theory of rationality, the individual would look at the cost and benefits before carrying out any activity, and in equilibrium, the individual would choose the activity to the point where MC is equals to MB, where MB is the marginal benefit. In forecasting theory, the MC is the cost of acquiring more information and MB is the accuracy of the forecast. The point where MC is equals to MB need not be the point where forecasting error is pure random, which we get under rational expectations. Information is not free but scarce, and this can be obtained, and thereby extra accuracy can be achieved only by paying the price which is not worthy. The counter argument against this is that the MC of information about the forecasting error is negligible or close to zero. Now let us summarize what we have learned in this module. The role of expectations is crucial in determination of output and employment in an economy. Expectations are tough to measure due to unavailability of data. Adaptive expectations are those which are formed on the basis of past behavior of the economic variable. Fourth, expectations are said to be rational when they are formed on the basis of all the available information. Under this assumption, expectations are never biased. Fifth, rational expectation hypothesis is superior to the adaptive expectation hypothesis in that the former never results in systematic error in forming the expectations. There are many applications of rational expectation hypothesis. The policy ineffectiveness proposition implies that when expectations are rational, expected changes in the money supply cannot bring about the changes in the output and employment. Phillips curve analysis under the rational expectation hypothesis predicts that there is no long-run trade-off between inflation and unemployment. Rational expectation hypothesis is based on the assumption that people use all the information, but sometimes due to the ignorance, people may not take into account all the available information. Another criticism that relates to rational expectation hypothesis is that information is scarce, hence costly.